Alright, so here's a summary of what we just learned today on the last video. Summary. To find min, relative, right? Relative min, relative or max, or where it's increasing, where the function is increasing or decreasing, or where the function has its critical point. Okay, we have to use the first derivative of the function. First derivative of the respective function. Okay. I am emphasizing this because it's not always just the first derivative a function. If you want to look at the maximum or minimum of velocity, remember? So here was an example that we went over yesterday, actually. If I ask you what is the minimum of the velocity, let's dissect this sentence here. Because we see the word minimum, we know that means the first derivative. And we're going to connect that with the velocity. So our respective function this time is the velocity. So in order for us to find the minimum of velocity, we need to take the first derivative of the velocity. So to find minimum of velocity, v sub t, we have to find the first derivative of v sub t and take a look at that. And we know the first derivative of velocity is acceleration. So that's what we're looking at. Now, here were the steps. So to find the min or max of a function, we had to look at the first derivative. So we took the first derivative. That is the very first thing that we did. And then we figured out where is the first derivative equal 0. And remember the reason why we figured out where it's 0? If we found out all the zeros, that means the rest of a function is not zeros, which means everything else will have a value. So we found the zeros, and once we do, we do a little number line. We do the number line to however many zeros we get. So x equal this, x equal that, and x equal that. And at those points, my first derivatives were zeros. And then we figured out, okay, we plugged in the values in between these numbers to figure out what type of signs these things had. And that helped you to find whether or not the function was increasing at the interval, decreasing at that interval, or if it changed from positive to negative, right? If it changed from here's my 0 and changed to positive to negative, that means it went like this, right? That's my visual. Positive slope, 0 slope, negative slope. That creates a maximum. If I were to go from negative slope to 0 to positive slope, that means I have a negative slope, 0 to positive. That's my visual right there. That means it created the minimum. So this number line analysis right there, that thing is called number line analysis. Helps you to figure out what's happening to the original function. What's happening to the respective function. It's telling you all about the first function. So we're using the first derivative to tell what's happening with the actual function, actual original function. So as long as you know these steps, the rest of it you can just kind of sit there and play with some algebra. So just keep telling yourself, okay, so if it's min, max, increasing, decreasing, or critical points, we are taking the first derivative of the respective function, whatever the function is, and that first derivative of that function gives the minimum or maximum of the value. So if I want to know the minimum or the lowest acceleration, I will take the derivative of the acceleration and do the number line analysis and figure out where it's 0 and figure out what's happening in those intervals.